So we are almost full, which is quite good for a meetup. So welcome to Google's and our first WebAssembly meetup. So thanks to Michael.
Yeah, hi, my name is Michael. I am technical program manager on B8. And toilets are there, food is there, beer is there, feel free to take. And snacks are also there and non-alcoholic beverages. If you want to go for a smoke break or something like that, please make sure to go outside of the building and that somebody with a badge like this escorts you. Yeah, you need to be escorted by Google all the time, more or less. So, and if you have questions, simply ask somebody who has a badge like this, and hopefully he can provide you with some answers. Thank you very much. Thomas.
Okay. Thank you, Michael. Thank you, Google. So, for those that don't know, part of the WebAssembly team from Google is working here on a different level. And we also have 3 members here from the team. So, Stefan is going to give a talk. Andreas is going to give a talk, and Clemens is also here. And their boss, Ben, is currently on a conference. But yeah, so it's a great opportunity to have this meetup here about WebAssembly, because here is where WebAssembly is made at Google, also in California. But I think this is a great opportunity for us to learn about what WebAssembly is. So the idea of the meetup was essentially there's not so much information about what WebAssembly really is. There's a lot of hype. And I think you have quite some different backgrounds. So maybe just a show of hands, who is a JavaScript developer here? Okay. So let's say 2/3 or something like that. Who is a native developer, so to say? Yeah, like 40%, something like this. So this is a bit difficult to give an introduction to JavaScript and native developers because of their very different backgrounds. So what I can do is, and what I will do is give a short flight through what WebAssembly currently is at, what's the state of the art, and what the idea is, what its potential is. But what I cannot give is a thorough introduction to everyone, because most of you will already have heard 1 or 2 Hello World WebAssembly talks, WebAssembly and JavaScript are best friends talks, stuff like this. If you're interested in talks like this, I will recommend a few online, but I think we have 3 very interesting talks, 2 from Google and 1 from Nidin about. One is, the topic has changed a bit about the module format, because this is at the core of WebAssembly. If you want to understand WebAssembly, you have to understand what the module is and what you can do with it. Then we have a talk about how you compile C++ code to WebAssembly, and we have a talk about compiling TypeScript to WebAssembly. So TypeScript, JavaScript developers know what TypeScript is, kind of backfitting, retrofitting types to a typeless language. And they're kind of taking it a step further. There are a couple of experiments. One is called AssemblyScript, which we will hear about today, which essentially says, okay, we will take this typed JavaScript language, cut out all the parts that don't fit to WebAssembly and that make code maybe slower, and try to compile it directly to WebAssembly. So it should be interesting for both native developers and JavaScript developers. There's also Rust, which you've also heard probably, that Rust tries to become the language to compile to WebAssembly. We don't have a talk about this today, but maybe in one of the next meetups. So I don't want to make this very long. One thing is I will try to bootstrap a kind of WebAssembly community at webassembly.eu. I've also created a GitHub organization where I will just share a bit of example code in the future. I've just added a few Hello World examples there right now, and I've created some Twitter account where I will maybe share some information, some news about WebAssembly, because I think this is currently what's missing, at least for me. There's a lot of hype, but there's not a lot of news. There's not a lot of information. What can you really do with WebAssembly now? What's planned for the future? Will we get DOM access or not? This is one of the most favorite questions, but there's no real answer there. So last year, in November, but all the major browsers support WebAssembly now. So if you have any of these browsers in a recent version, you can just use WebAssembly. This is a minimum viable product. It's not really all the features you would want, but they wanted to ship this out of the door. I think it's a miracle that 4 browser vendors have agreed on something to ship. Yeah? This has not happened in the last 20 years, I think, since JavaScript. JavaScript had a long stagnant period, and during the last 5 years they made great progress, but there were a couple of attempts like Google Native Client and other attempts to really bring native code to the web, and none of them really got cross-browser support. So within, I think, a year or so, the browser vendors agreed to standardize this and ship it in their browsers. And this is really something that I've not seen in my career so far. So first JavaScript I wrote in '95, so I've been waiting for about, how long, 20 years for something like this to happen. So there will also be like polyfills. You can compile native code to ASM.js. So ASM.js was a kind of subset from JavaScript, where you would kind of use a couple of quirks from JavaScript to make it more efficient in the VM. So for example, JavaScript doesn't have integers. You could pull off some tricks that the VM actually understands these are integers and can optimize your code better. This is actually Ben Titzer. I think he's the project lead of the WebAssembly team here in Munich. He's not here today, but I think if you really want a good in-depth introduction to what WebAssembly is and how it works, I highly recommend his YouTube talk, which was published in February. And I will later share the slides if you're interested, and just have a look there. So what are the use cases for WebAssembly? Should we now write all web pages in WebAssembly instead of JavaScript? So currently there are, I think, 3 use cases. One is you have an existing native application that you don't want to rewrite. The second is you have a native library that's very optimized, for example, for video codecs, for audio codecs, for computer machine learning, computer vision, any stuff like this. You can now just compile to the web and use there, yeah? Which is kind of amazing. For example, there are a couple of image algorithms you can just use now. If you write new code, then you could use WebAssembly for parts of your application that need to run fast. For example, JavaScript is notorious for not supporting multi-threading at the moment, at least. And also, for example, if you want to have predictable performance, that means your application needs a frame rate of 60 frames per second or a constant stream of audio, video processing. This is where JavaScript sometimes stutters, and this is one of the advantages they expect from WebAssembly. There are a couple of demos that show what you can do with WebAssembly. One was the Zen Garden demo that most of you will probably have seen. So the Unreal Engine, which is a 3D graphics engine from Epic, a game company, has compiled their C++ code to the web, essentially translating C++ code to WebAssembly binary, and also translating the OpenGL calls to WebGL and also the audio. If you want, then maybe we can have a short look. Let's see if the recording is still on. So this is, for example, the Zen Garden demo running in Google Chrome currently. So it's using WebGL. It's based on the Unreal Engine. You can just, for example, navigate around. See if it works in the beamer. Kind of difficult. Okay, so essentially, I can send you the link. Just downloads all the code, all the textures, compiles the code, and then runs this engine in your browser. So maybe I need to restart it or something.
Probably the recording is messing it up.
Sorry?
Probably the recording is messing
There's an error down there.
Could be, yeah. So the error about IndexedDB, you can just ignore this. It's just cache. So now you can see how long it takes to load currently. But in the future, this would only have to be loaded, I hope, one time, and then it's kind of cached. So it has downloaded the code, has built the graphics shaders, it's compiling the WebAssembly code. Takes a few, let's say a minute or so, and then you can see the demo. Shall we wait for it? Maybe I'll show it afterwards if you still have time. Yeah?
Sorry for the newbie question maybe, but so do you always have to compile, or can you, I mean, assembly sounds like
you don't need to compile assembly code? Is that the question?
The question is, what is the experience of a user?
So, I think this is something...
Depends. It depends. So you have a bytecode and you need to compile it to machine code so the machine can actually execute it. But there's works on the way to cache the compilation, the machine code already. So you don't need to recompile again.
So we will cache in the future, but currently it's like you press download the WASM file, then it gets compiled. It means it's a very shallow compilation. I would say it's not like you compile a high-level language to assembly code, but WebAssembly is almost machine-level code already. It's kind of an abstraction from the different CPU architectures, and then it compiles for the current CPU architecture you have, and then it's instantiated, and you can just run it like any other JavaScript.
There are also other tricks like streaming compilation, so while you're downloading already start to compile and stuff like that to really hide the compile cost for the user. So user experience, so in the end that the user experience doesn't suffer.
Yeah, maybe let's
multiple tricks.
Keep the questions for the end because I only have 15 minutes. So let me just show you around the garden. Yeah. So one other big application that will come to WebAssembly is Google Earth. So before it was implemented in native client, which was only running in Google Chrome, but now they are porting it to WebAssembly. They demoed it a few months back, and you can find the video on YouTube. I will also post the link, but for you it's maybe interesting to see WebAssembly is actually used for something instead of the Zen Garden demo. And what's more is Autodesk. You probably know AutoCAD, the construction software where you can build, for example, buildings, anything like this. The code is like 35 years old, and they've compiled it with WebAssembly to the web. So this is a really huge application with really old code, and you can run it now in the browser. Yeah.
Demo for does it take to compile?
Sorry? How long it takes? Maybe 50 or so. I don't know, I haven't tried.
It's not bad. No, it's actually quite useful.
Yeah, so it's less than 10 seconds currently.
Yeah.
Okay, but you do part by part or so, not you don't compile the entire application.
So I don't know what exactly AutoCAD is compiling, but if you open it, if you start it on a desktop machine, it takes less than 10 seconds.
Okay.
So it actually takes hours to compile AutoCAD natively.
Yeah.
So it's
amazing. Yeah?
that cannot be true. I mean, that would be a kind of.
No, on the desktop we
yeah.
compile with like more than 5 megabit per second.
Mm-hmm.
So.
Yeah. Okay, so web compiling WebAssembly is actually not really a lot of work compared, for example, to compiling C++, because it's almost compiled, right? It's as you can see here.
It's just a translation.
This is, for example, the translation between an add function in C++ to WebAssembly. Essentially, what you do there is, like, for example, if you take native code, you compile your code to a machine language, then it would look kind of similar. So you have a native CPU instruction, an add instruction for example, integers 32-bit, and WebAssembly kind of abstracts a bit the differences between CPUs. Right? So you can essentially compile any language to this machine level, close to machine level language. And the compilation then is not a lot of work anymore because maybe it works a bit differently on ARM processors than on x86 processors. But essentially it's not so different. You don't have to parse a lot of header files or stuff like this. So it can even be streaming compiled. So while the binary is downloading, it can already start compiling. So this is the same how it would look for TypeScript. So this is AssemblyScript or Vault. There are different variants how you can do this. For JavaScript developers, it should look kind of familiar if you use TypeScript, or if you don't, then just imagine the types being erased, and it will directly compile to the code below. So if you compile a simple example like this, the resulting binary is like 90 bytes. It's not even 100 bytes, yeah? Which I think is very efficient. This is not true for all the languages. For example, if you compile C++ or Rust code and you use a couple of libraries in your code, for example, for string formatting in Rust, then you easily pull in 200 kilobytes of just string formatting code, which is currently a bit of a problem. But just to illustrate the point, when these languages are optimized, or we have a better way to use these languages in WebAssembly, the resulting code can be very short and very easily transmitted. So what is the idea, or what are the advantages of WebAssembly? The performance is close to native code. So they're talking about, I don't know, it varies a bit, about 20% or so you lose of the native performance for the security checks. Maybe you can add something there later. I think it varies from example to example. I think it could be also 50%, but currently I think in many cases it's kind of comparable to the JavaScript performance, and sometimes it's faster, sometimes it's slower, but where it will really shine is once you can leverage, for example, multi-threading. SIMD means you can, for example, compute vectors or arrays of all this of elements that always do the same computation more efficiently, because the CPU supports doing this in parallel, which you cannot do currently in JavaScript. It has a very secure sandbox, which is kind of a point where people say, well, I don't trust this. We have seen this with Java applets. We've seen this with Flash. We've seen this with whatever ActiveX or whatever nightmare you had in your browser. And there were always big security issues. But the sandbox is really on a very low level. That means they check if your code accesses outside the boundaries of the memory that has been allocated to the module. And I think they also separate between data and instruction code. And I think this is a very good model. And the thing that's kind of new about this is per module. So if you have several modules of these, you could sandbox them each on their own. I've never seen a language or framework that actually lets you sandbox your code by module, which I think is something that could be quite interesting in the future. It's kind of a portable executable format. So for example, me coming from an HPC background, where we did simulations on a PowerPC, on SGI and stuff like this, a huge problem for native code is always you have to compile to this machine architecture. You have to compile with this compiler. This compiler version has a bug, something like that, and then everything breaks. You have to support a lot of different systems, and I think I've wasted about 1 year of my time to make it portable to any of these supported platforms. And this problem kind of can go away with WebAssembly. You just compile to WASM binaries, and the compilation is done for you when you run the code. And as you heard, it's quite fast, the compilation, because there's not much to do. And I think one of the chances is currently the web community, like having JavaScript and native developers in one room is already kind of a miracle. I think it has the potential to bring down the language barriers, because essentially inside your module, you can pick any language you want, as long as your interface to the outside world is compatible with other WebAssembly modules. So you can say, well, I want to write this in Rust, and you can write it in Rust. I want to use a 35-year-old Autodesk library, you can do it. Or if you just want to continue using your JavaScript code, you can also do it. And it's all running in the same thread. It's not a different process. It's not a microservice you have to start up, anything like this. This is very efficient, I think. Still going back between different formats, how the languages represent data structures can be a problem that is currently worked on. But I think this is something we will hear more about in the future. And there's also WebAssembly. So the assembly part is not really the assembly of a single CPU architecture, but it's kind of an abstraction of this. And it's not really for the web only, but the concept could already be used. For example, there's a project that's an operating system, Nebulet. It's an experimental operating system that lets WebAssembly modules run in ring 0 because they trust the security model so much that they say, we don't need all the different rings of kernels, user mode, and so on. You can just run your code in ring 0 safely, gain performance, and the performance you lose by abstracting from the real assembly code, you can actually maybe gain by just running it in ring 0, which will mean you can just run your native code as fast as before, but you don't need to compile it to a specific architecture. Yeah, so how does it work from JavaScript standpoint? So you call a compilation function. There are different ones like streaming compilation. That means you download the code, and while it's being downloaded, it's already being compiled. You instantiate the module. All of this, I think you all know better than me. And currently, JavaScript is in control. It can compile the modules. It can run the modules. But it could also have a different embedding in a different system. JavaScript is not the only possible host language for this. But for the web, it will be, I think. WebAssembly cannot access the DOM directly at the moment, but I think it's actively being worked on, but there's not a lot of things I can share where I can say, well, this will be in 5 months or 5 years, or it will be in this or that way. There are currently a couple of proposals. But I think it's definitely coming, would be my standpoint. The module format, as I said, is most central to WebAssembly. This is there's no executable, there's just the module format. There's no distinction between executable and module. You can compile different languages to it, as I described. It's kind of a assembly language similar to the native ones you have for certain processor architecture. As I said, it's sandboxed by module, not per process, and portable, safe, fast. These are the main buzzwords they're thrown around. The binaries can be quite small, like I said, and they could potentially be shipped via NPM, like any other JavaScript module. Just run npm install, and you install. You don't have to compile 4 hours. For example, the Boost library, you can maybe just take a module that has already been compiled to WebAssembly and just install it in a couple of seconds. Webpack and Parcel already have support for WebAssembly. And yeah, maybe I think I'm already over time. So WebAssembly is kind of a brainchild, I think, of LLVM. It was called low-level virtual machine, which is no longer called because it's a bit misleading. But essentially, LLVM did the same for native code. Has some kind of intermediate representation that's being compiled to different CPU architectures. I will maybe skip this, will be too confusing. There was also the native client from Google, which they've now deprecated in favor of WebAssembly. But I think this sandbox idea, I'm not sure, sounds quite similar to what WebAssembly is doing, maybe, and has been inspired by native client. It was never cross-browser, that was the problem. But I think the ideas live on in WebAssembly, which is quite good news for me. If you have heard of ASM.js, this is actually the predecessor of WebAssembly. This was, as I said, a subset of JavaScript that made it more efficient to run code in JavaScript. And essentially, you could compile C++ code to ASM.js. And now you've switched a flag in Scripton, which we will hear about, and it will compile instead of ASM.js to WebAssembly. So far for my talk, I think I'm already over time, 5 minutes. Still, I would like to show you, maybe it has finished compiling. Okay, recording and showing it at the same time is a bit difficult. So the performance is not like this if you don't run QuickTime in the background for recording. Essentially, this is how the Unreal Engine looks in the browser. I will send a link around. And here you see a couple of screenshots from Google Earth running with WebAssembly. Here's the talk from AutoCAD. I think I will just paste the link and send you the slides. What else is there? So I just mentioned the WebAssembly.eu website. So I just bootstrapped a small website where you see some recent news about WebAssembly. For example, there has been a port of PS PDF kits to WebAssembly. They're comparing the different browser performances. The Commodore C64 has been ported to WebAssembly. Vim, there are a couple of Rust examples. You can read about AutoCAD or how you publish Rust modules on NPM. And I think this is one thing I think is missing, and I will try to add more information about WebAssembly there. Yeah, so sorry about the videos so before it was working, but I think I will want to conclude with this and hand it over to Stefan. Thank you. Any questions? Or many questions?
In a hello world, you need to call JavaScript.
Can you make the question
In
more
your
precise?
hello world, you need to call JavaScript to display the hello world.
So you mean if you want to display it in the browser, for example, in the DOM or in the console, yeah, you need to essentially. So currently, maybe that's one thing I've forgotten is that inside of WebAssembly you cannot actually display anything. You always have to call out to JavaScript currently, yeah? And this is currently not so easy because, for example, strings are represented differently, but it's actively being worked on. But I think the state that WebAssembly currently is in it's shipped, but it's probably not for widespread use yet. There are certain areas where you can already benefit from it, for example, like codecs or big applications you want to compile to the web. But if you really want to write a web page in WebAssembly, that's currently just inefficient.
That's what you. I would suspect that's what one use case you probably
Or
still want to have
JavaScript.
in JavaScript anyway, because it's simply easier to debug and maintain.
Yeah, debugging is a different topic.
Yeah.
Yeah. All right.
So think about ASM.js use cases. A lot of people that we know of that are using or were using ASM.js are switching to WebAssembly because it's simply better, and yeah, it's suffice for the same use cases currently. So high performing stuff like codecs, for example, or dimensions.